So let's start the interfacing of LCD with 8051. So LCD is finding widespread use instead of LEDs just because of the fact that they are able to display all the ASCII characters on it. They are also able to display some what we call the graphics also. With the help of these ASCII characters itself, we can generate some graphics. Fine. So I'm talking about that kind of LCD. It's not LCD TV. I'm talking about the LCD which you see on the you might have seen. Yeah, the best example is calculator. You might have seen on the calculator, that kind of LCD display I'm talking about. So that LCD display is available on your this 8051 interface, this 8051 AD simulator. This is your LCD interface. Fine. So I'm talking about this type of LCD interfacing. Fine. So this type of LCD, if you wanted to interface with 8051, how will you interface? Because normally when you are designing some projects and some embedded system, then you normally prefer a LCD which displays display some value, or display some parameter, or display some status. Fine, whether it's running, whether it's off, or whatever it is. So you wanted to display some value, so you use that particular display. Normally these displays, LCD displays, are very these are very frequently used in embedded system designs. Fine. So let's look at this. These LCDs, these type of LCDs are always 14 pin. I've googled n number of LCDs which are available for interfacing with ready-made boards also, even Arduino boards also, and various microcontrollers. All are 14 pins. Fine. And today we'll be using LCD which is already interfaced with the this EDSIM51 simulator, that is our Toshiba. Fine. So we'll see its datasheet also. Normally all are 14 pins. The first three pins are used for the purpose of power supply. Fine. The first three pins are used for the purpose of power supply. The first pin is the ground. The second pin is the 5-volt supply, while the third pin is also power supply, but you can increase or decrease its value. Fine. This is very interesting. You can increase or decrease its value. If you increase its value, the contrast becomes higher. When you reduce its value, the brightness becomes higher. Fine. So if you wanted to have a bright just white LCD, you supply a value equal to 0. If you wanted to have a complete black LCD, you supply a value 1 for complete 5 volt here. It's a 5 volt IC which I am talking about. Every IC has different voltage level. Fine. So I'm talking about 5 volt IC. So if you supply 5 volt here, it would be complete black. If you supply a 0 volt, it would be complete white. So you usually take a medium value. It depends upon the user what value it takes. Fine. And the fourth pin is RS pin. This is very important pin. This pin is used to define whether you wanted to whatever value which you are giving to LCD, is it a command or is it a data which is to be displayed on LCD. Fine. So for every interfacing device which you are interfacing with 8051, there is a differentiation. Either you give a command into the command registers, or you give data into the data registers. Fine. Any interfacing IC, if you read any interfacing IC starting from 8255 general interfacing IC, 8279 DMA controller, any interfacing IC or any interfacing device, it has two types of interfacing: data and command. Fine. So here also, if you wanted to give command from the 8051 to the LCD, then first you put RS equal to 0. This RS is a register of LCD. You put RS equal to 0. Now whatever data which you will supply from 8051 to the LCD, it would be command. And when RS equal to 1, and then whatever data which you will give from 8051 to the LCD, that would be the data which is to be displayed. Fine. Now the fifth pin is read or write. read is written here and write is written below. That means it's read, for read it is active high, for write it is active low. That means if you put it as 1, if you put this pin as 1, then it means you are trying to read the LCD. Fine. You can also read whatever data has been displayed onto the LCD, you can read from that LCD. Fine. Although normally this pin is not used, this pin only is always used for writing, because we only wanted to display something on the LCD rather than taking data from LCD. Fine. So for writing on it, you should put that pin equal to 0. Fine. Now the enable this E pin number 6, this is also very important. You put a pulse, here, we'll see in a example. You put a pulse here, high to low, pulse high to low, and this pulse will be useful for buffering the data. Fine. So for example, if you forward a character from 8051, or just a value, just don't see as a character, if you forward a value from 8051 to the LCD, then you have to give some time for displaying. Fine. Because LCD is slower, but 8051 or any other microcontroller, they works very fast at a speed of megahertz or gigahertz also. Fine. So what you have to do, you have to buffer it for some time. Fine. Then only the next character or next value can be displayed. So for that purpose, you have this pin. On this pin, you put a clock, put a high to low value. Fine. So that the value which has just now came onto the LCD, it would be buffered. Fine. And rest of the 8 bits, rest of the 8 pins are used to connect with the 8-bit data bus of the 8051 or any microcontroller. In today's lecture, we'll taking the 8051. So here with these pins, pin number 7 to 14, which are 8 pins, so you can directly connect any of the one port of 8051. Fine. Let's see. These are the commands which you give from the 8051 to the LCD, or indirectly, where I could say that these are the different commands which are acceptable by LCD. Fine. So what are these commands? Let's see. We have already seen that by putting this pin number 4 to 0 or 1, we can select whether we are giving command to the LCD or whether we wanted to give our data to the LCD for displaying. So if we put RS equal to 0, that means we are giving command to the LCD. What can be the different commands? These are the different commands. If we give data 1 to the LCD after entering the command mode, if I give data 1, it means you clear the display, LCD will clear the display. If I give 2, it will give it means return to the home screen, return to the home. It means that the LCD is this much big, the cursor may go here, here or anywhere. So if you put 2, that means the cursor should come to the home. Home means the first character. If you put 4, it means decrement the cursor will go toward left. 6 means cursor should go towards right. 5 means to shift the display towards right. 7 means shift display towards left, and so on. So these are the many commands to control the LCD. These commands are used to control the LCD. Fine. Once you give the command, once you have given the command, now you are ready to give data to the LCD which is to be displayed on the LCD. Fine. So this is one of the example program, and this is the connection. Look at this connection, we'll see the program, we'll understand the program, and then we will simulate one of the example program on the EDSIM51. Fine. So let's see this. This is the LCD module. This is the 8051. What we have done, the data pins of LCD, that is from D0 to D7. Fine. We have connected to the port 1, complete port 1. P1, the first pin of port 1, P1.0, to the last pin of port 1, that is P1.7. So we have connected the data bits of the port 1 of 8051 to the D0 to D7. Fine. Then the RS pin, which is very important, which is used to select whether we are giving command to the LCD or whether we are giving data to the LCD. So that is connected to port the pin 0 of port 2. Fine, this is just a single line, so we have connected to the pin 0 of port 2. Fine, the read write pin, we have connected the read write pin to the first line of port 2. We have connected the enable pin to the second line of the port 2. Fine, then we have connected supply to the 5 volt, we have connected the VSS to the ground, and the VEE to a particular voltage level, depends upon where this rheostat, this is a rheostat, varying resistance, where we have put this varying resistance for selecting the brightness and contrast of this LCD. Fine, so let's see what this program is. This is a sample program. Before starting it, we should remember some points, that to give command to the LCD, just make RS pin equal to 0. Fine, so how to give RS equal to 0? It's very easy, because you have connected the RS pin to the port P2.0. so just making this port P2.0, this pin port 2.0 as 0, you can make this LCD to work in the command mode. Fine, so and if you wanted to provide data to LCD, then you should make RS equal to 1. Fine, then you should call a time delay before sending next data or next command. Fine, this you should remember, because I've already told you, you should remember this while doing your projects also, physical projects also. You should remember this while programming your physical project. What you should do, if you are sending a data from the microprocessor or microcontroller to the output device, then if you already sent one data, then you should wait for some time, so that the output device should settle down, because the devices or the memory or any input output device, they are very slower as compared to the microcontroller or the microprocessor. Fine, so you should wait for some time. How to wait in the programming? I've already told in my last lectures. To wait means you have to use a delay. Fine, so that's the same thing which has been given here. You should call a delay after sending the next data or the next command to the LCD or any other module. Fine, this is the connection which we have already seen. Now let's quickly move to the program. The first line of the program was already always org0h. It's an assembler directive, which means that from where in the code memory you are starting your program. So in the code memory, I am starting to write my program at the first location 00h. Move 38h to the A. That means I am giving a value 38 to the A, and then I am calling a subroutine. I think you all people know what is subroutine. Fine, so I am calling a subroutine command write. What is that subroutine? It is command write. Fine, already A contains 38. Now I am calling a subroutine command write. Let's see what is that subroutine. Now your program will jump to that subroutine. Fine, so let's see what is that subroutine. This is that subroutine command write. In this subroutine, what do you have? A, the value of accumulator, that is 38, will be moved to the port P1. Fine, what is port P1? The port P1 is connected to the data port of the LCD, so 38 will move to the data port of the LCD. But wait, the 38 will be available at the port 1, and it is also available at the data input pins of the LCD. But what needs to be done? Whether 38 need to be displayed or 38 is a command, it is yet to be given. So let's see. First you clear this bit. What is this instruction? This is clear instruction. That means clear means you make this value as 0. If it is set B means you are making the value 1. If you are writing CLR means you are clearing means you are making that value 0. So CLR P2.0, that means you are making the first pin of port 2 as 0. Let us see what is first pin of port 2. The first pin of port 2 is connected to RS. Fine. That means you are making the value RS equal to 0. You are making the value RS is 0 by clearing this pin. Fine. RS equal to 0, that means you are trying to write a command. Fine. Now clear P2.1. Clear P2.1. Let's see what is P2.1. P2.1 is read write. When it is 0, that means you wanted to write on LCD, so it is cleared, so you are writing on the LCD. Now set P2.2. Set P2.2 means you are making it 1. Set means 1, clear means 0. So setting P2.2 means you are making it 1. So what is P2.2? P2.2 was E. That means you are putting E as 1. Fine. E as 1 means high pulse. High pulse means, let's see. High pulse means so high pulse means just a minute. Yeah, high pulse means this. What you are doing, you are setting bit P2.2. So at port 2, what will happen? It will be high voltage. Then what you will do after some time, see, I have called a delay. Called a delay means it will wait for some time. Fine. And then I have cleared the P2.2. Cleared the P2.2 means this will become 0. Fine. So this is a high to low pulse. Fine. This is high and this is low. So what has happened? You have given a high to low pulse at which pin? Pin number P2.2. You have given a high to low pulse where pin number P2.2. Fine. So you have given a high to low pulse at pin number P2.2. What is P2.2? P2.2 is E. So whenever you give high to low pulse, that means this command, whichever command you have given, I have given this command. This command on where I have given this command? I have given this command at I've given this command here. Now what kind of command it is? It is the value A. What is inside A? It was 38 initially. So 38 has been moved to the data input. Fine. Now LCD will determine what does 38 mean. 38 originally meant as, let's see what was 38 mean. Just a second. So 38 originally means you wanted your LCD to be 2 lines of 5/7 matrix. Fine. The display of your LCD should be within 2 lines of 5/7 matrix. Fine. This is the command which you have given. Now this is completed. Last line is return. Every subroutine has last line as RET. RET means return. From where you have come, just go to the same place. So from where you came from this place. I have called the command right here. So you came from here. Now this line will be executed. What is this? Again a delay has been called. What I have told you, that a delay will be called after every command or after every data. You should remember this. What is this delay subroutine? This is just loop within the loop. Fine. This is loop within the loop. So it will remain here for some time until the LCD will settle down. Fine. I have given some values 255 and 50. So this will remain here till 50 multiplied by 255 multiplied by the frequency of the 8051. For that much time it will remain here. Fine. Then next command is 0E. Again I am calling the command subroutine, so that will also be done. 0E means whatever 0E means. 0E means E means display on, cursor blinking. So your display will become on and your cursor will start blinking. Fine. So all these commands, this is how you give the command to the LCD. all these things mean this how you give command to the LCD. Fine. After this, after you have given the commands, whatever command you wanted to give, you have already given the command. Now you give the data. How to give the data? Let's see. Move a comma n. Move a comma n. So what does it mean? Within the inverted commas, it means you are not giving n. This is not the number n. This is the ASCII value of n. Whenever you give a letter within the inverted commas, that means you are supplying the ASCII value. Fine. Because your computer system, your 8051 doesn't CPU doesn't understand the letters A, B, C, D, E, F. Fine. It only understands the binary numbers. So all your these characters have been coded into the ASCII numbers. I need not to explain here what is ASCII number. So when you put the inverted commas, that means A will contain the ASCII value corresponding to n. Fine. Now you call the data write subroutine. Data write subroutine is what? It will cause the LCD to display this value. Fine. What is data write? Let's see. That particular value move to the port P1. What is port P1? P1 is connected to data port of LCD because we are supplying the data. Now set bit P2.0. Set bit P2.0 means you make the P2.0 as 1. What is P2.0? P2.0 is RS. When you make RS equal to 1, that means you are using the data mode. That means you wanted LCD to display. So make RS equal to 1, and similarly you will make the P2.2 P2.1 also equal to 0. Initially also you have make it equal to 0 when you are putting the command, because you are writing onto the LCD. That's why you will make this pin this P2.1. P2 means writing. Fine. And then again by these 3 instructions you will make the signal on this E pin as high to low pulse. Fine. First you set it, then you clear it. That means high to low pulse. High to low pulse will mean what? That whatever data you have given in the accumulator, it will remain, it will go to the LCD and it will remain there for some time. That means this high to low pulse. And then the last line of every subroutine is return. Return means go again from where you came. You came from here. Fine. Then again delay, and then the next character which you wanted to move. I wanted to move O, so I've put O in the accumulator, and then again call to subroutine to display, so it will again display. This is how your program works. Fine. So let us quickly see a program in the EDSIM51. Let's see a program. Just a second, let me make it. So this is a EDSIM51. I have a program of LCD. Just wait for a minute. I have a program with LCD. Yeah, this is LCD. This is the program for LCD where I wanted to display yes. You can display anything. Fine. So I wanted to display yes. For example, let us write a program for hello world. First we'll simulate this yes, then we'll change it to hello world program. So what we have done, we have put this Y, E and S, all our characters. We have put these characters inside the RAM of 8051. The particular place of RAM is 30H. At the 30H we have put Y. At 31 we have put E. At 32 we have put S. How to put into the RAM? I have already told you. Either you can go to the this data memory, and directly if you wanted to write at 30 what Y, then you should know what is the ASCII value of Y. Then that particular ASCII value you can write here. You can just put 30, and that particular ASCII value, it would be written here. Or either you can do by a program, which we are doing here. So by program, how to move it? Just write y, move to 30h. So y will be moved to the 30, E will be moved to 31, S will be moved to the memory location 32. The last line should be 0 because it would be useful in the program. Let's see. The last line should be 0. The last location should be 0. है ना? Let's see why. Now these are all the commands which is to be given to this LCD. Let's see what is this LCD is. This LCD is HD44780 of Toshiba. Fine, which is a 16:2 LCD. Fine, 2 rows with 16 characters with each row. Fine, this LCD is already available in our EDSIM 51. Therefore we are using this LCD. Fine, this LCD needs to have these many commands to operate it in 4-bit mode. Please remember, this is operating in 4-bit mode. I have not told you what is 4-bit mode in an LCD. 4-bit mode means at a time only 4-bit of data can be sent to the LCD, whether it's a command or whether it's a data. Only 4-bit can be sent to the LCD. You cannot directly send the entire 8-bit. In contrast with this example, where we are connecting the entire port P1 with the data port of the LCD. Here what we are doing, we have to use only 4 bits of any of the port of 8051 that would be given to the LCD. Fine, because it is to be used in 8-bit mode. Oh, sorry, 4-bit mode. Fine, because this Toshiba version only works in the 4-bit mode. Let's see its diagram also, logic diagram, then it will be more clear to you. In its logic diagram, you can see that this is the LCD. The port P1, the bit number 0, 1, 2, 3, 4, they all are connected to the data ports of LCD module. Fine, they all are connected to data port of LCD module, and let's see which will be used to move the data and which will be used to move the command. Let's see. Fine, in the program. So these are the functions. These are the see, this is for 4-bit mode. To enable the 4-bit mode, you have to write all these commands. Fine, so these commands needs to be hardwired. They needs to be written. Whenever you wanted to use LCD for any kind of display, you need to write them. So we need not to go deep into this because this is specific to HD, this version HD44780 of Toshiba. Fine, so we will directly go to the entry mode. We will directly go to the display. We will directly go to the send data because we wanted to send data. Fine, so the first line of the program should be defining the memory, that what is inside the memory. Fine, and then we will directly come to our program. This is our program. First you put P1.3 as set. Set means you make P1.3 as 1. What is P1.3? P1.3 is connected to RS. This we should look into the logic diagram. The P1.3, this pin should be connected to RS. Let's see, this pin, yes, this is connected to RS. Fine, this is connected to RS. So what we do, since we are now moving the data, all commands we have already moved, now we are moving the data, so we will make this pin as 1. How to make this pin as 1? We just write 1 here. We will just write set P. Set P means make this pin as 1. When you make this pin 1, then your RS will become 1. That means you are sending the data. Now what you do, you put 30 into R1. What is this 30? 30 is the location of the data inside the memory, because we have already fixed the location. We have already fixed the location that at 30H our first data is there. Fine, so what we have done, we have put the 30 into the register R1. Now we will use this register R1 as the data pointer. Fine, this register 1 is pointing towards the data which is at the location 30. Fine, now you move that value which is at 30 into a. How to move that? Just write move a comma at the rate r1. What is at the rate r1? At the rate r1 means whatever data is at the value of r1. What is the value of r1? Value of r1 is 30. So what is whatever data at the 30, at the rate r1 means at the 30, at the location 30, at the location 30 is y. Fine, so that y should be moved to a. So now what a contains? A contains y. Fine, this is saying that if it is 0, jump. If 0, go to finish. Is it 0? No, it is not 0, it is y. It has some value, so it will not go to finish. It will execute the next line. What is the next line? Send character. So send character is our subroutine to display the character on LCD. So this is our send character. What it is doing? It is what I have told you. It is a 4-bit mode. Fine, in the 4-bit mode we have to send 4 bits at a time. Fine, how we are sending it? Where is that data? That data is on the accumulator. Fine, so we will access each bit of accumulator. Please listen it carefully. We will access each bit of accumulator, and then that bit will be sent to the data bits of LCD. Fine, so first we will take the last bit of accumulator. We move to the carry flag. This C means carry flag. Fine, we can do the bit movement in 8051. I have already told you in my last lectures that we can do the bit movement in 8051. So we have moved the 7th bit into the carry flag, then take that 7th pin bit into the port P1.7. What is P1.7? Let's see in the logic diagram. P1.7 is connected to the 7th bit of data. Fine, similarly 654, all these are connected to 654 bit of pins of LCD. Fine, so let's see again. We have already moved with these two instructions. We have moved the 7th bit of accumulator. There we'll move the 6th bit of accumulator. Here we'll move the 5th bit, and here we'll move the 4th bit. So only 4 bits will be moved at a time. Please remember, only 4 bits will be moved at a time. This is 4-bit mode of LCD. Fine, so once we have moved the 4 bit, now what we'll do, we will put a high to low pulse on E. This I have already told you. Why do we do this? Because once we move some data, then we have to wait for some time. How to do that? We put a high to low pulse on pin number E of what? Pin number E of LCD. So pin number E of LCD is connected to P1.2. We have seen in the logic diagram. So first we set it to 1, then we clear it. Set it to 1 means high and clear means low. So high to low pulse. Fine. Then we move the last 4 bit, the most significant 4 bits of accumulator. The 3rd bit, the 2nd bit, the 1st bit, and the 0th bit. Fine, so first 4 bits and the last 4 bits. Fine, then again we will wait for some time. How to wait? Just put high to low pulse on E and then call a delay. Why do we call a delay? Because we have to settle the LCD for some time before displaying another value. Fine, so we'll call the delay subroutine. What is delay subroutine? Let's see. Delay subroutine is a simple value 50. We have put a loop. The 50 should be decremented to 0. Until 50 is decremented to 0, it will remain here. Then it will go to the same place from where it has been called. It has been called here. It will go here. Again it will be decremented till 50. Now it will return. It will return to its original place from where it has been called. It has been called from this subroutine. There. Now it will be incremented to R1. Now this instruction will be executed. What is this instruction? Increment R1. increment R1 means now you are incrementing the value of R1. What was the original value of R1? It was 30. Now after incrementing, what it will become? It will become 31. Now you again jump to the same location. Loop means this location. Now you move new value of R1 to A. What is new value of R1? New value of R1 is 31. So what is at the 31? At the rate R1 means at the 31. At the 31 is next character. At the 31 is next character. Let's see. At the 31 is next character. Fine. So this next character would come into the A. Fine. That's next character came A, and then again you will check whether it is 0 or not. No, it is still not 0. So it will call the subroutine to display. That would be displayed. It will come back again here. R1 will be incremented. R1 will keep on incrementing until it gets a 0. That's why I have taken the last location as 0. When you encounter a 0, R1 will be at the last location 33, which contains a 0. So what happens? Let's see. When R1 is pointing towards 33, then that 33 contains 0. It will be moved to A, and it will check whether it is 0 or not. Yes, this time is 0. So go to finish. Finish means last line. Finish means jump to nowhere. Jump to nowhere means dollar. Dollar means nowhere. Nowhere means the program will still remain here and nothing will be displayed. Fine. So after displaying all these characters, the program will remain there. And what is this character? Y, and then E, then S. That means yes. So let's see whether it's displayed or not. I all recommend all you to please go to this program more clearly, because in just live session this program may not be very clear to everyone. So I recommend everyone to go through this program. Let's load this program. Yes, the same program has been already loaded here. Now what you'll do, I'll again load in front of you how to load the program. Just go to load, and whatever program you have written in Word file, just locate that program, double click, and it will be displayed here. Fine, it's displayed here. Now go to assemble. Assemble means it has been assembled here. Fine. Assemble means it has been saved into the code memory. Now you run it. First see the LCD. What LCD is showing? LCD is showing nothing. You can change the frequency 100 times, 100 units of this frequency. Fine. And you run it, and then your yes is displayed here. You can see. Fine. Now you can display any string rather than yes. Let's see. With the same program, let's display something else. One very good thing with this simulator is that you can directly change the code from here itself. Rather going to the editor, you can directly change the code from here. So we will change our code here itself. Put the reset, go to the reset, and then it's an editor in front of you. Let's write something. Hello world. HEL. So what we are trying to write hello world here. So I've written a hello world here. HELLO, then a space. This is space. Space also needs to be given because space has its own ASCII value. Fine. WORLD world, and last value is 0. Fine. Now you have to take care of this location also. 30, at location 30 it is H, at 31 it is E, at 32 it is L. Now it would be 33, 34, 35, 36, 37, 38, 39, 3A and 3B. Fine. Now you have changed the value. That value should be displayed on the accumulator. Once you reset it, your LCD is also reset. Now assemble it. Let's see whether it's an error. Yes, there is an error. I am forgotten to put a inverted comma. It will give you error. Fine. I'll again assemble it. So it's successfully assembled. Let's see it's running or not. I'll run it, and H is displayed, ELLO WORLD. So hello world has been displayed here. So with the same program you can display any string here. Fine. So all the faculties also, if you are using this simulator is very powerful. You can display in front of your students while you are teaching the LCD interfacing with 8051. Then you can show this simulator to your students, so that it would be very useful in teaching also. Fine. Thank you.